So we are starting on this example here, and we're going to continue with our arc length formula. So the running lanes, believe it or not, this rainbow looking thing is the end of a track. The running lanes at the Emory Sears track at Bluffton College are 1 meter wide. The inside radius of lane 1 is 33 meters, and the inside radius of lane 2 is 34 meters. How much longer is lane 2 than lane 1 around one turn? Okay, so don't go exactly with what you would think about a track in one turn. Go with the picture here. Okay, go with the picture, go with how it describes it, and we'll go from there. Now, okay, pieces of information. It shares that what? The running lanes are 1 meter wide. So if I'm trying to get some labels in a picture, then that means this right here is 1 meter. This right here is 1 meter, correct? Just trying to get a visual for you. The inside radius of lane 1 is 33 meters. Do you understand what they're saying there? Yeah, the radius of, we have this half circle or semicircle here. So that means the center of the circle is, it's the idea if, okay, center of the circle is approximately here, if I eyeball it, right? And so the inside radius of lane 1, so that means, I didn't get that eyeballed exactly right, but the inside radius goes from here to the inside of track 1, or lane 1, and that is 33 meters. Then it goes on and says the inside radius of lane 2 is 34 meters. So that's going to the inside of lane 2, which is the line in between the tracks, and that is 34 meters. Does it make sense that they're 1 meter difference?
Yes.
Yeah, because the width of the track is 1 meter. So that should hopefully make sense to you. And then let's see. How much longer is lane 1 than lane 2 than lane 1 around one turn? Okay, we wrote this up from Friday to today, from a pre-recorded video to a live, Mrs. Sargent. But what did you learn on Friday in that video? Yeah, we had an arc length formula, yes? And that's what we're looking at, is this is a portion of a circle. Okay, this is a portion of a circle. If you think right here, okay, like this is half of a circle. So this is a portion of a circle. Arc length is measuring the curve of a circle. So like arc length measures a portion of the circumference of the circle. Does that make sense? Okay, so we want to know how long lane 1 is and how long lane 2 is. Now, let's do them one at a time here. Let's talk lane 1. What is that arc length formula? Theta. S equals R theta.
Is it theta like TH?
Theta. Theta. Okay. What? There's several different letters that they use for angles, but theta is a common one. Okay, so S equals R theta. S standing for the length of the arc, yes. R is the radius. What's the radius of for lane 1? From the center to the inside is 33. Now, here's the question. What's theta? Okay, so if we look here, this line makes what kind of angle? And it makes 180 degrees, yes? Is 180 degrees what I get to put in my formula? No, because 180 degrees is degrees. When we use this formula, it's specific restriction is it has to be radians. What is 180 degrees in radians? Pi. Okay? And so this is 180 degrees, or it is pi. And so we're going to use pi here. Now,
If you took, I use well, I mean, if you use the rating formula, you just 180.
Yeah, I mean, it's one of those things I know. So, but yeah, so like if you go from 0 at 3 o'clock to pi at 9 o'clock, that's pi around. That's 180 degrees. It's also pi around. But also think about the relationship. On Friday, you were told to multiply by, if we're trying to go from 180 degrees, how do you go from degrees to radians? You multiply by pi over 180. Yep. Yeah, and so I guess I could put that over here. So if I'm trying to change 180, multiplying by pi over 180, the 180s cancel, and thus it is pi. Is that the visual you needed there?
Yes.
Okay. So, silly question here. What is 33 times pi?
33 pi.
Keep it easy. 33 pi. Now, that was lane 1. Let's talk lane 2. Again, using S equals R theta to find this arc length, to find the length of that piece around the circle. What is R this time?
34.
This time my inside radius is 34. What's theta? The same, yes? Aren't we running that same? Isn't the angle the same? Yeah. So 34 times pi is 34 pi. What did the question ask? How much longer is lane 2 than lane 1? So what do I need to do? Yeah. We're going to subtract, and we're going to do lane 2 minus lane 1, which lane 2 is 34 pi, minus lane 1, which is 33 pi. What is 34 pi minus 33 pi? 1 pi, yes? It's just like doing 34x minus 33x. Pi makes a like term. And so this is going to be pi, which, what do your brains know about pi? Because I'm not going to go out and try and say that, oh, P ran pi longer than you. I'm going to go with 3.14, and this is meters. What?
That's why it's staggered.
Yep.
It's not very complicated. I'm not late 80s done this for.
Okay.
I mean, if you didn't run track, you can put the skull under in lane 8 to the field.
Okay, moving along. Refocus. Okay, guys. You like me to be honest with you, right? Okay, I need your 100% focus, because if anything's going to catch you in this lesson, it's going to be this. Okay? Angular and linear motion. Okay? Now, we're going to use the idea of what I call dimensional analysis, where you're multiplying fractions to convert units. Okay, you guys have done it probably prior in math. You've definitely done it in science classes. Okay, so I don't think it's a new technique, but there's just some new relationships here that we have to work on. So, angular speed is measured in revolutions per minute, or what you have probably heard of as RPMs. You might have an RPM dial on in your car. You might not. Okay, yep, revolutions per minute. Okay, can be changed to linear speed, measured in miles per hour, in conversion factors like we use to change radians to degrees. So remember when you're changing radians to degrees. Pi and 180 are equal to each other. So when you multiply by pi over 180, or 180 over pi, you're multiplying by 1. Okay, so looking at our example. Albert's truck has wheels 36 inches in diameters. If the wheels are rotating at 630 RPMs, rotations per minute, find the truck's speed in miles per hour. Okay? So, we've got some conversions to do here. Now, One thing I need to comment before we get going, and actually I'm going to write it right in here because this is a key detail to being able to work this problem, except you can't see where I wrote. Okay, so a central angle. So an angle in a circle, right, of 1 radian big intersects an arc the length of the radius. Okay, and this is just a piece of information to know, so I'm going to write this down. A central angle of 1 radian. So radian being a measurement here. Intersects an arc, so an arc of a circle, the length of the radius. I'll read that again. A central angle of 1 radian intersects an arc the length of the radius. What I'm saying is that 1 radian is equal to whatever your radius is in the circle.
No matter what the radius is?
In that particular circle, no matter what the radius is. So that's one of our conversion factors we're going to use. Okay? Yes?
When we measure something that spins, are we going to measure from the farthest part out?
I'm not understanding the question.
So, like for the wheel, like a wheel moves faster from the outside than it does from the inside. Like a turbine or something. So, like when it says,
it's still so many rotations per minute.
okay.
So, okay. Let's see. What do we know about Albert's truck? Wheels are 36 inches in diameter. If the wheels are 36 inches in diameter, what's that tell you? Okay, so you guys are catching on that we're going to have to know the radius, yes? So I'm just writing it down here, is that the radius is 18, what are we talking? Inches. Gotta get my labels right. So 36 inches in diameter, we all know is equivalent to 18-inch radius. And the other information we're given? 630 RPM. So rotations per minute. And what are we trying to find? Miles per hour. So we're trying to take this rotations per minute that we have, and we're trying to convert it to miles per hour. So rotations to miles and minutes to hours. Now, where I'm going to start, we're going to do this all in fractions. And I'm going to start with 630 because 630 was our given number, correct? Now, 630 as a fraction is 630 over 1. Okay? Nothing surprising there. Now, what was my label for 630? Because labels are important here. It was RPM. So that is, in their words, rotations per minute. So 630 rotations per 1 minute. Now, trying to think, we can use rotation, but a rotation, okay? Another word for rotation that I tend to use here, and I'm trying to think why, is a revolution. Does it make sense that 1 rotation around a circle is equivalent to saying 1 revolution per circle? So when I label this, I'm going to label this 630 revolutions per 1 minute. Our goal when we get to the end of this problem is to have miles over hours. You can. I think it gets confusing because I think it gets lost, but you can if you want.
I don't want to put M and then mix it up with meters.
Notice I did not just put M.
Oh.
M is not minutes because M is meters. And MI is miles. So you have to use MIN for minutes. Just, exactly, it can get confusing. Okay, so our goal is to get to miles per hours here at the end. Now, we have to change revolutions to miles, minutes to hours. What's the easy one to do here? Minutes to hours. What do we know about minutes and hours? 60 minutes and 1 hour. So when I teach this, I'm going to say, okay, we're going to multiply by a fraction. It's either 60 minutes over 1 hour or 1 hour over 60 minutes. Your goal here, we want minutes to cancel. Minutes is where currently? On bottom. So if we want minutes to cancel and it's in the bottom, where do I put minutes in my next fraction? On top. So that means I'm going to put minutes over hours in my next fraction. And what was that relationship between minutes and hours? 60 minutes, 1 hour. Because, so now what happens? My minutes labels will cancel. And I now am at the point of revolutions per hour. Is revolutions per hour what we want? Of course not. Okay, so now we've got to get from revolutions to miles. 1 revolution around the circle is what? Okay, so, and you could, for some of you, it might come more naturally to say 1 revolution around a circle is 360 degrees, yes? However, I'll be honest, we're not going to talk degrees on this problem. We need to talk radians. So you need to think instead 2 pi radians. So 1 once around the circle, 2 pi radians. You might write that down as a side note somewhere that that's always a connection to make. Now, okay, over here, revolutions is on top, yes? So my options are 1 revolution over 2 pi radians, or, I want revolutions is on top here, so I want revolutions on bottom here, yes? The connection we're doing is 1 revolution is equivalent to 2 pi radians. So that right there is one of the tricks you're going to have to remember, that connection right there. Okay? The idea now, revolution canceled. So now, it's a weird label, but I'm at radians per hour. Not very helpful, but we're making progress, I promise. Now, we don't know a lot about radians, but there's a little starred asterisk mark up above. In this particular situation, on Albert's wheel, 1 radian is equal to 18 inches. Because, what did it say? A central angle of 1 radian, which aren't we in radians right now? 1 radian intersects an arc the length of the radius. So 1 radian equals the radius. Radius in this problem is 18 inches. Now, am I saying 1 radian is always 18 inches? No, it's whatever the radius is. So now, okay guys, 50-50 shot. 1 radian over 18 inches or 18 inches over 1 radian? Okay, we're going to want the 1 radian on bottom and 18 inches on top. And notice, why am I doing this? Radians cancel. Okay, so look and see where we're at. We had hours way back here. I'm at inches per hour. We need to get to miles per hour. So now it's just a matter of getting from inches to miles. What do you know about inches? 12 inches in a foot. That's a good place to go. Because then can feet get us to miles? If you know the deal, yes. Okay, so 12 inches in 1 foot. 12 over 1, 1 over 12. And here's the deal, guys. Look at what label has to be on bottom. We want inches to cancel. Since inches is on top, I want inches to cancel. So 12 inches is 1 foot. Now, I'm erasing this goal here that I just... Okay. I now have, I don't know why I wrote foot, I should have done FT, feet per hour. What do we know about feet? Okay, 1 mile is 5,280 feet. If feet is on top right now, where do I put feet so it will cancel? On bottom, which means miles will go on top. 1 mile, 5,280 feet. And what cancels here? Feet. What remains? Miles per hour. Did we make it? We got our labels. Now, here's the next.
5,280 of what?
5,280 feet is 1 mile. That's probably a challenge for you, because you guys do everything in metrics, don't you?
Yeah.
You're not going to know that one very well. Okay. Whereas for us, metrics is more the challenge. At least for me it is, I know. Okay. Now, here's the next challenge. Can you get the correct answer using your calculator? Okay. What's the gist of what we have to do here? We have a whole bunch of numbers on top. We have a couple numbers on bottom. There's right ways and wrong ways to do this, is what I'll tell you. You've got to find a way to make sure you know what you're doing. Debating what I want to tell you to do here. Okay, so options. If you have a fraction bar, I'm going to set up a fraction bar. And what are my top numbers? 630 times 60 times 2, and I'm going to use the pi symbol, times 18, times 1, which I don't need my ones. Then I'm going to go to the bottom of my fraction, and what am I putting? 12 times 5,280. This is one way to get your calculator to do what you want it to do. If you get this answer, you have found an appropriate way to do this on your calculator. Now, if you don't have a fraction bar, you can do parentheses around the entire numerator, divide by sign, and then parentheses around the entire denominator. Okay? Another option, it's 67.47 if you're curious, is if you didn't use a fraction bar. 630 times 60 times 2 pi times 18, and then you can do divide by 12, divide by 5280. That gives me an equivalent answer. I don't know. We could have also 630 times 60 times 2 pi times 18, divide by, I could do parentheses, 12 times 5280 in parentheses. So many different ways we can do this. I would encourage you to practice something now and in homework so that when you come back later, woof, that got really big. In this one?
Still got 67.
Because I was dividing by anything in the denominator. The 12 and the 5280 were both in the denominator.
So you divided it by 12 and then it divides it again by
Uh-huh. Or it's divide by and you put parentheses and it multiplies both. Again, there's lots of different equivalences. Okay, final answer. 67.47 miles per hour. And I will have to zoom. There we go. Okay, guys, you'll see one or two of those in homework. Will you see something on this come quiz test time? Yes. Okay, so you do need to practice this.
This is a lot.
And with practice, it's not bad. You already know a lot of those, connections. It's the connections to make sure you work on. Remember, 1 revolution is 2 pi radians, and 1 radian is equal to the radius. Those are the 2 connections to remember.
So
Okay.
one full rotation is always going to be 2 pi radians.
Yes, always. That fraction will never change. Okay, one last quick, easy thing.
So that was one of the only things that I was like,
Yeah.
thinking about. Other
And
than
that-
that, it's just converting.
And it's just the idea of once around a circle, so that's 1 revolution, or 1 rotation around a circle, is equivalent to, we could say 360 degrees, or 2 pi radians is the equivalent. And that's never changing. Okay, One last set of information. There's not much to stress about here. A nautical mile is length of 1 minute of arc along the Earth's equator. So nautical mile, we're talking about what boats use, right? We're talking about what you see in the ocean. A statuette mile is what we consider the familiar land mile. So our traditional mile is a statuette mile. The conversions between nautical and statuette miles are as follows. And they give it both ways. In fact, a statuette mile is approximately 87/100ths of a nautical mile, or a nautical mile is approximately 1 in 1500 statuette miles. These conversions are equivalent, or very, very close to being equivalent. So you can use either one depending on which situation you're in and what you're most comfortable with. The example that uses this. Megan McCarty, a pilot for Western Airlines, frequently pilots flights from Boston to San Francisco, a distance of 2,698 statuette miles. Her flight time calculations are based on nautical miles. How many nautical miles is it from Boston to San Francisco? And they told me 2,698 statuette miles. What am I going to do if I want to find out how many nautical miles? Okay. One option is to multiply it by 0.87, which is probably the direction I would go. However, it will be approximately equivalent if you divide by 1.15. Now, if you want to think a fraction, like the fraction set up on what we did on the last one, 2,698 statuette miles over 1, and then that means if statuette miles is on top, we put statuette miles on bottom. So 1 statuette mile for 0.87 nautical miles. And then, of course, grab your calculator, do the math. If you did it the other way around, you had 1 nautical mile on top, 1.15 statuette on bottom, you're dividing. Here on the calculator is the difference between the two answers. Sometimes they're a little closer than that. This one, they're a little farther apart. I obviously would allow for that on a quiz or a test. Okay. They're still both in that same ballpark of 2,346 or 47. Which, when you're talking that many miles, 1 mile difference is not a huge thing. So, 2,347.26 nautical miles is what I'm going to write down because that's what goes with the calculations I wrote down. Okay, you did not write it down at the end of the video. Here it is again. The homework for this lesson is page 325. You may have already started it. You may not have. 2 through 42 evens. 45, 50, and 51. This homework is due tomorrow. You have about 5 minutes right now. So you could technically be looking at it. I'm not sure if that's, depends if you even have stuff with you or not. Well, you could use this 5 minutes. You don't have to get your book out to get your paper headed and stuff. Those type of things, Write it down.